It's rare these days to find something new. It's even rarer to find something game-changing new. But this software could change the way we make things. This video is sponsored by Flux. You know, I get to work on some weird and wonderful projects at times, and that's great because I get to try a lot of new things, I get to experiment with stuff, and I absolutely love doing that. Now, every once in a while one of these projects comes along that has me considering designing sort of custom PCB or a custom circuit board. And I've got to let you in on a little bit of a secret here, but for quite a long time I've sort of fallen out of love with doing that. And it's really down to the software that is available in this space. Typically it's called EDA or ECAD software. And at one end of the scale you've got like stupidly expensive, overpriced and seriously overrated pieces of software. And on the other end of the scale, you've got these amazing free open source tools, which is just wonderful, the amount of community support that goes into them. But if I'm kind of honest, the user experience I find can also be quite frustrating at times. Now, in today's world, there's a lot of electronic modules that are just already being built, and certainly at the prototyping stages of a project, the need to design PCBs has sort of gone away a little bit. Nevertheless, the project that I've been working on for a while has led me down this path. So I guess I wanted to share that journey with you with a new piece of software and the surprising sort of position that I ended up in. The project I'm working on is a new type of AI solution. No, not an LLM, but a solution that will need to be tested with certain types of real-world applications. And so I wanted to create a testing jig that would let me hook up some cheap servos to measure some repetitive actions over several days. If you missed the last video, I went over various testing stands and jigs that I make, and I just started to build the stand for this requirement. For the particular test that I want to perform, I don't need that much information or data from the motors. I mean, I'll be getting it anyway, but really what I want to test here or track is very small, microfine and consistent movements over time. The long form of this test will involve dynamically adding weight, and that will change an AI's interaction with its motor neurons, and it's much more complex and it's long term. It's a story for another day, but for at least now, what I know that I need is an inertial measurement unit test or an IMU chip that can detect the movements. I started by looking for a 6-axis IMU that could be easily powered and controlled by an ESP32, and I came across the MPU 6050 module. It's just a fraction too big for what I want, but I decided to check out the product page nonetheless. The MPU is made by TDK and is part of their InventSense line. But the first thing the product page shows is that it's already been superseded by a new chip, the ICM-42670-P. So now the journey begins, and I take a look at that product page as well. It looks pretty great, but I quickly found out that unlike the older MPU, outside of development boards and flight controllers, there doesn't appear to be many, if any, single chip modules available. So now that moment of dread sets in, and I just think this is really gonna suck. But I thought, well, why not take the opportunity to have a look at, what's new in the world of EDA and ECAD software, at least potentially try something new. And that's what led me to the sponsor of today's video, Flux. From the first moment of landing on the Flux website, I got a little tingly, because immediately after reading through product pages and data sheets, it was sort of ringing in the back of my mind that an AI should be doing this type of legwork for me. And here, staring me in the face, was a new tool with AI built in from the ground up. Right, I have to admit, laying out a new PCB is actually the part that I enjoy doing the most. But in saying that, it's also the part that gives me a lot of anxiety. So to see they've got an AI-assisted routing solution, well, I knew right then and there that I had to try this solution. It's super simple to get started, and you can create a free account. And then my next question was, could it actually perform as good as it looks? I've got to say, after so many decades in software engineering, there's not much that gets me excited enough to want to use certain things. But rather than just jumping straight in and expecting it to be like other types of EDA and ECAD software, the first thing I did was went to their YouTube channel so I could watch some videos and maybe get a feel for it. So here you'll find enough to start building a mental model of how the Flux solution works compared to what you may have been used to. They've got a bunch of great content in here, even if you've never designed a PCB before. You can really pick up a lot here. For those of you who have never tried to design a PCB before, the first stage is actually figuring out who's going to make the boards for you. Now, there's lots of options out there, and I guess that this is part of the problem because they're all different. They've all got different requirements. Some PCB manufacturers require this type of setup, others require that type of setup, depending on how many layers the board will have. It can be really time consuming and really complex just to get the project set up. Well, Flux makes this stupidly simple. You just click to start a new project using a template made for the company you want to use. In my case, you guys know that I work with PCBWay, so I just search for them. 4-layer board, perfect. That's all we need to start. So what's next? Well, normally this is where we'd start pulling down data sheets, we'd start researching, and we'd spend hours or days, if not weeks sometimes, researching all of the components and the bits. And I thought, hang on for a minute, let's just see how good Flux really is. I mean, after all, isn't this supposed to be what AI is for? Shouldn't it be doing the research for me and saving me all of that time? So we don't start looking for components to add to our schematic. The first thing we do is turn to the built-in Copilot assistant, and we want to tell it about the project and any of the other relevant details that it should know from the start. Of course, it can also request some information as well. Soon enough, Copilot has come back with a ton of information about the components that I want to use, including details of the pin layouts and a bunch of components to use as well. In some cases, a new beta feature will offer to place the components for you on the schematic. It didn't do that here, so I'll just find and place the components separately. Pretty amazing, right? I mean, I've done very little here to get this project up and running, and already I feel like I'm not alone. I feel like I've got something or someone that's helping me along the way. Of course, in even bigger, more complex projects, Flux's Copilot could go through and plan the whole thing out for me as well. Now, like almost all other types of AI, they make mistakes, and Copilot in Flux is no different. So it stands to reason that you spend a little bit of time just reviewing what it said and actually making sure everything stacks up. I'll always give the datasheet a quick scan, and particularly I'm looking to ensure that both Copilot and I are on the same page, so to speak, by resolving the datasheet pin numbers and what Copilot has in its context. This is looking pretty good. One of the coolest new features in Flux Copilot is called Knowledge, and you can see how it just detected it. When you tell Copilot something that it doesn't know, or let's say you want something done in a particular way, it recognizes it, and you get the options to basically imprint your knowledge into Copilot. You can choose to keep this in secret squirrel mode just for you, of course, or you could share it at the project level or for anyone else on your team, or if you let anyone clone your project, you could also allow them to benefit from this as well. It's safe to say that I was pretty impressed by the implementation of Flux's Copilot. I mean, yeah, we could all go and use ChatGPT, to get the information back, but that's the point. The value here is the integration, not just the information. All right, time to get on with designing this circuit board. Now I'm just going to take my time here wiring up the schematic to the pinout, finding components, and you'll see I'll refer back to the instructions from Copilot along the way. I've added a jumper here to enable me to control the chip select mode of this board as well. Now, really good practice to sort of get used to when we think we're done is to click on the net names to see that everything is connected in the right place and the right net names are assigned. You can see here that I made a simple but crucial mistake, so I'm glad I caught this at this stage. When we finish the schematic view, I don't know about you, but I tend to just want to jump into the PCB layout and design, the fun stuff. But I can't tell you how many times I've just wasted hours of routing and tracing because at some point I find out I'm missing a component or I've got the wrong component in there. So asking Flux Copilot to do a review of the schematic before I go and waste all that time, it sort of felt like a cheat code. I mean, it's an insurance policy, right? Tell me what I'm missing. Tell me what I've done wrong. Give me all of that information before I move on. Now, I want to see just what sort of curveball I could throw Copilot here. Would it notice that I was missing a decoupling capacitor on the VDDIO line as per the datasheet requirement, or would it mistake the bulk capacitor for it and just tell me everything is okay? That's pretty damn cool, I think. I swap out the generic cap as well and add the new decoupling capacitor. Okay, one last time, let's get another check to verify everything again. Now we switch into the PCB tab and we can see from the 2D view that all our components are ready to connect up with wire traces. Before I do that, I tend to want to clean up the components to make it a little bit easier to work with. And this is where the rules and properties of Flux really allows you to do some pretty cool things. When we select any component on the board, in the Inspect panel, we can see that there are all these properties that we can either set or read the values of. Some of these rules are set globally for the project, or they could be part specific, or they could affect how the item looks, performs, or is laid out, for example. So here I want these really big component labels to be hidden. They kind of annoy me, so I just create a new rule set to do this. If I select one of these labels and take a look on the Inspect panel, I can see that its designator is the term value. So I create a new rule set, and over here I create the selector to grab all the value elements like this. I then need to add a simple layout rule. These are all the different property types and sort of rules that I can apply to lots of different things throughout Flux. Now I add the value of false, and next to it I add the exclamation mark important value, and this tells Flux to overwrite the default behavior. I'm also going to create another rule set to reduce the font size of these label designators as well. All right, we're looking good. You know, laying out and routing PCBs, it's a form of engineering artwork. Now, I'm not claiming to be the best. I'm nowhere even close to being the best. But there are some people out there that they just have this creative ability to make those PCBs look absolutely beautiful. People like Phil over on his channel, Phil's Lab, are pros, and you can learn a lot from watching them at work. One of my favorites is Sion from Unexpected Maker. He just knows how to make this stuff look next level. Unexpected Maker is, of course, a great friend of the channel, and you can find the links to their website and YouTube channel in the description down below. Now, the process I'm about to do may not be the same way that everybody else does it. It might not even be the right way, but it's just the way that I learned how to do it and the way that works for me. I was always taught to get the board layout sorted first in terms of dimensions and positioning the centerpiece of the design. In this case, I've got a tight physical constraint of 15 by 15 millimeters with 2.5 millimeter rounded corners on one side. So I'm going to get the board size and shape sorted first, along with the placement of the mounting holes. When they're in place, I'm going to lock these components so I don't accidentally bump them and nudge them, but also they're going to serve as alignment tools for the other components. Next, we're going to get our centerpiece sorted out. Now, not every PCB will have a single centerpiece chip, but there usually is a primary chip, for example, that you want to get positioned first. In this case, we're dealing with movement, so I want to get the chip placed in the absolute center of the board and then lock it as well. In this particular board, the pin headers are going to create the maximum amount of space I have on the board to place components. So I'm going to get them located as well, although I can move them around and finalize them to suit as we go. Next, I'm going to go back and forward between the schematic screen and the PCB screen. I can select one or more components in the schematic and they will be automatically selected for me in the PCB layout.
Generally speaking, we want to get the power related components sorted out first. Our decoupling and bulk capacitors need to be placed pretty close to the chip pins, so I'll go ahead and get them placed. These bigger capacitors are making it really tight in here, but with some careful movements we can get things lined up with the rat lines or air wires connections as well. I'm going to slip in and out of the 3D view so I can get a good look at the pad locations and move as I need to. Okay, I know it looks like a bit of a mess at the moment, but PCBs on these small footprints always sort of seem to do, but we'll clean it up as we go.
Layout is in what I would call a semi-finalized state. Now, while I could still move some of these components around, once we start wiring stuff up, moving these components can cause a long tail sort of list of issues. It can break other trace paths, it can break sort of the really important stuff. And that's why I tend to finalize the layout now before I start this wiring. Now again, way back at the start of the video, I talked about this approach that Flux has using a manufacturer's project template, how it just saves so much of the aggravation and trying to get things set up. This is where this really shines. I mean, we're about to start wiring things, and inside this project template, it already has the three most common wire or trace widths defined within it. And so we just don't need to worry. It's already in the project. My number one rule when starting wire routing is to always do power first. If you select the Objects tab over here and go to the 3v3 in the Nets collection, we can then go to the Inspect panel and see that the trace widths are provided for us in the template. I've done these calculations before with PCBWay trace widths that are found on this page. PCBWay generally suggests 6, 10 and 20 mil trace widths. So when you convert them to micrometers denoted here by the unit of measure, you get 152, 254 and 508 micrometers. So I'm happy to leave the values that are in the project template. So let's start routing the power, and I'm going to concentrate on the capacitors and bringing the power generally from the chip pins out. When routing a trace, you can just click and drag, and you can keep hitting the W key to cycle through the trace widths. You can hit the F key if you want to change the angles in the trace as well. You'll notice that I'm narrowing down the end traces right near the chip to ensure we get the right amount of space between the pins. If I had specific components with radio signals or things like impedance matched traces like we get in USB connectors, then I'd also be doing those here at this point as well. I'm also going to route all of my ground pins at this point from the primary chip, as well as the capacitors, and of course the header pin as well. The reason I do it this way is because I want to give these specific traces the most amount of room, as well as the most amount of copper in the traces. With power and ground done, now comes a really cool feature in Flux that I was super interested in trying. This is called auto layout. It's Flux's AI going through an iteration after iteration, trying to optimize and finish off the wire trace layouts for us against the DRC rules that it needs to adhere to. Now, you can imagine just how much time this could save on really big and complex projects.
So now we're in a great place in terms of our foundation routes. We just click the auto layout button and pretty much just watch it all happen. It can take several minutes for this process to complete, As I said, it's an iterative process. So if you keep watching it, you'll see traces magically being routed and then in some cases disappearing. This took 13 minutes to complete, so it's pretty much coffee time for me when I click the button to start. But when it does complete, you can move the slider back down through all the iterations and observe how they changed over time. You can accept any one of these just by clicking on the apply button, but for the most part, the last iteration is going to be the most optimized. So I'm gonna go ahead and select that. All right, so now just take a look at the 3D viewer to ensure that all of our components are close enough or not blocking each other.
That's kind of like some voodoo magic right there. Right? And even though I might have to go in and make some tweaks, make some changes, figure a few little bits and pieces out, the amount of time that just saved me, even on this little project, is kind of crazy, right? I mean, we're in the final steps now, so I've just got to go back in, tidy some things up, change some rules around, maybe add some silken bits and pieces, and we'll see where we end up.
When we're ready, we can just come over to the F menu when we go down to the export and select to export the manufacturing files, which are the Gerber files. Now look at this for amazing. The Flux guys will review your designs for free and make sure you've not forgotten anything before you spend money on manufacturing it.
That sort of support is what you're getting with Flux. I'm not kidding. You can even get a one-to-one call with Flux to learn how to start using it completely free of charge.
You can find that here in the Learn section just by moving through the carousel and then click on this to book it.
Now, some people out there are going to say, of course I'm going to say nice things. They're sponsoring the video, right? Are you serious? Do you really think if what they created was an absolute pile of garbage that I'd be willing to put it on here? That's the unwritten rule between you and me. The things I show in here also have to benefit you. And I take that really, really serious. I got access to Flux a few months ago and I spent a lot of time pulling it apart to really make sure this was the real deal. That's how serious I take it. And we did that a long time before Flux and I agreed to do a sponsored video about it. I hold software experiences to a really high level. I have to. I've done it for so long that you've got to be doing something great to impress me. And not many companies do, including the biggest companies in the world that of course are just putting out rubbish and absolute crap constantly. In this particular case, Flux absolutely knocked it out of the park. Now I want to say this, if you've never designed a PCB before, or maybe you've thought about it, or maybe you've tried it but you found it was really complex, a little bit overwhelming, give this a try. You'll be amazed at what that support of the AI integration can do to help you get through from end to end. And not just that, the support of Flux and the community in it is absolutely amazing. Give it a try. Don't Don't try and design or build something crazy to begin with. Don't do an ESP32 module or anything. Just take one component and try and create your own module. Maybe copy a module you've already got. That's the way to start. Equally, if you're a professional and you've got years and years and years of experience in EDA software, if you're open to trying a new system, maybe seeing a different way to work smarter and faster, then I really think you should give Flux a look. Now, it's not going to work the same way as your existing EDA software does. I hope this video has shown you enough to show you that it doesn't. It's a different way of working. It's more progressive. It's a new way of working, and the AI integration is insanely good. All right, maybe you'll end up in the same spot as me, where thanks to Flux, I think I've fallen back in love with designing PCBs. Pretty big statement, I know, but that's true. I've absolutely enjoyed working with it. Now I'm going to put the links to obviously their YouTube channel and their website down in the description below. You can get a 2-week free trial. You can sign up. That's enough time to really get in and play with this and see how you go. And of course, all of that support is there as well to help you get started as well. There'll also be other information down in the description, our channel sponsors, our friends of the channel, and other ways to support me and to support the channel as well, which I really appreciate. That's it for another one. If you've liked this content, by all means hit that thumbs up button. You know that that really helps YouTube as well as me to understand whether it's the right sort of content that I should be creating. If you're not a subscriber, I don't know why we are taking a while to get to 1,000 subscribers. Yay, that'll be the milestone that we're looking for. So if you're not a subscriber, hit the subscribe button. That'd be wonderful. And of course, say hello in the comments. Introduce yourself. And to the people that have already done that, say hello again. Everyone will tell you, I love interacting down in the comment section. I answer all the comments as much as I can. Everything is there. All right, I am the Old Man Maker. Take care of yourself. I'll see you in the next one.